right. I think the sound's a lot better now because I actually have the shit this time. Audio input capture. Let's do this. So now you should hear me better. All right. So, I'm just gonna wait for people to come in. I'm gonna just write, I guess, HPC review 2023 midterm. It's chapters 0 to 4. And if I remember correctly, chapter 0 is linear and quadratic. Chapter 1 is what is chapter 1? I don't remember what chapter 1 is. Chapter 2 is like rational. Chapter 3 is exponential and logs. Oh, chapter 1 is the basics of functions. Chapter 4 is trigonometry. So, I don't have any specific questions. And the thing is, I don't have the book. So that's gonna be in trouble. In fact, I might try downloading it like right now. Um, so if you need specific questions in specific the book that you're using, I don't know if I can get it though. Let me see. Um, calculus, graphical. I can. Very nice. Amazing. Oh, functions and graphs, polynomial, power and rational functions, exponential, logistic and logarithmic, trigonometric functions. All right, so those are the so it's just the function test. Okay. So if I'm still going to wait for some people. If they don't if I don't see anyone in 5 minutes, I'll probably just start doing some stuff. If this would actually finish downloading, which is taking really long because I'm devoting my internet to streaming, not to this. But we'll see. All right. So put your questions in the chat if you want me to answer them. We have it can be from I think these are the chapters that you guys are being tested on. I'm not sure though. So, all right. He's offline. I might stay here for longer than an hour. I need to do some stuff after. But after that, I'll probably just do something while I wait. So yeah, I'll do something while I wait. Let's go to. Never stand tall. All right, my thing's actually nearly done, so that's very nice. Who would you rather? Who would you rather do it to, Eunice or Carla? Oh my God, you're a menace. Yeah, everything that you're saying right now is being recorded, streamed. So I know. If you don't care, then I'm fine with it. Ain't no way. Bro, I didn't even watch this. It's like a month streak. But why are you even recording? I'm streaming. I'm not recording. Oh, like Discord? No. YouTube. Wait, what are you streaming for? Precalculus. Oh. Review. Is this like the beginning? Or like you're just waiting for people to join? Yeah. I need questions. That's the. Okay, I got a question. What? I got a question. What's the question? For the pre-calculus review. I don't know. Then don't answer. I don't know anything to do with that. Is that for easy peasy 1 2 3 or easy lessons? No, it's probably just enough as banana bread. What is that? It's like one of those Fiverr edits. To see Republicans. Bro, just put a heart. Move that ski. Okay, it's finished downloading. That's very nice. All right. Um, this is the same. I know this is the same book. I don't know if it's the same edition. That's the thing. I have the 8th. The question should be relatively similar, so I'm not very worried about that. Um, All right. Yeah, the prerequisites are dumb. I don't think you guys need review on this at all. At all. All right, the first thing that you need review on is probably forms of a line. So there's three forms of a linear equation. There's three forms of a linear equation. I don't know if I have any questions right now. If I do, then I need to do that. Three forms are slope-intercept, which will become less useful the farther you go into math. Point slope, which is the by far superior one, and standard form, which is the worst one. Um, in the slope-intercept form, you have the form of y equals mx plus b, where m is slope calculated by the change in y over the change in x, or y2 minus y1 over x2 minus x1. And b is the y-intercept, and the y-intercept of a function is 0 comma b, right? It's not b comma 0, right? It's the y-intercept. It intercepts the y-axis. If it intercepts the y-axis, x is 0, not y. So that's something to be careful about. This is some very simple stuff, but if you make mistakes on it, that will be very detrimental. Point slope form. So slope intercept form, you can have 2 points, and you can use a slope intercept form. However, if you have a point and a slope, you want to use point slope. So if you have a point m, and if you have a or no, this is not a point. I'm sorry, slope m, and if you have a point x1 y1, then the point slope form is y minus y1 equal to m times x minus x1. That is point slope form. And if you multiply this out, which I'm not gonna multiply it out, you will have the slope is m, and the point is y1, or the y-intercept is y1 minus mx1. We're not gonna care about that though. Standard form is the third form, and teachers really like to test you on this, but it's absolutely useless. It's terrible form. It's ax plus by plus c equals 0. So if you have, I don't know, if you have a y equals 3x minus 1/2, and what you have to do is you have to make all of them integers. So a, b, and c have to be integers, or whole numbers, are integers. And what you will get is, well, this is negative 3x plus y plus 1/2 equals 0. But the 1/2 isn't an integer yet, so you have to multiply both sides by 2. Will get you negative 6x plus 2y plus 1 is 0. And that's the standard form. All three numbers have to be integers, and they all have to be on one side with 0 on the other side. Very annoying form. I don't like it, but it is relevant in this course, at least. All right, so that's the first thing that I found. So let me see if I can find something else. Okay. So two lines are, so if we have y equals mx plus b, if that's the equation of a line, then the equation of a line that's perpendicular to this line the equation of a line that's perpendicular to the line must have slope. So perpendicular must have slope. I'm gonna say this is m perpendicular. This is the symbol for perpendicular is equal to 1 over m and negative that. So negative 1 over the regular slope. And that's the perpendicular. If it's parallel, then the slopes are the same. Parallel, same slope. Same slope. Right? Even though it's the same slope, it doesn't mean it has to have the same y-intercept. Um, Even though it's the same slope, it doesn't mean it has to it has to have to be the same point, right? So point slope form, if you're using point slope form, the point can be different and it can be still be the same slope and still be parallel. If it does have the same y-intercept though, then the two lines are the same. They're the same line. So let's do a practice problem. Let's do Yeah, let's do that one. Why not? Line 2, find the equation of a line through 2 comma negative 3. What was it? And A parallel to the line 2x plus 5y equals 3, and B perpendicular to the line 2x plus 5y equals 3. These are really annoying forms. So the first thing that I would do is I would turn it into a slope intercept sort of form. You can't really use point slope here because even though you have a point, you don't really have a slope. So it's just more kind of convenient to turn it into something y equals something. So let's do that. 2x plus 5y is equal to 3. So 5y is 3 minus 2x, or y is 3 minus 2x over 5. So what's the slope? The slope is minus 2 over 5. So since the slope is minus 2 over 5, we have the point. We can do point slope form. So point slope form means y minus y1 equals negative 2 over 5 times x minus x1. That's the first equation. And perpendicular, y minus y1 is equal to m, which is opposite sign and the reciprocal. Opposite sign and you flip the fraction. So 5 over 2 times x minus 2. And those are the answers. Now you can simplify them. I don't know if you guys need to, but I'm going to just in case. Usually on a test, I probably just leave it like this. I don't know if you guys need to though. I think you guys do. So this is y plus 3 is equal to minus 2 fifths x plus 4 fifths. So y is equal to minus 2 fifths x minus 11 over 5. This is y is equal to, or y plus 3 is equal to 5 halves x minus 5. So y is equal to 5 halves x minus 8. And so these are the answers, and these are the answers. All right. Let's see what's next. Let's do inequalities. Complex numbers. inequalities. Let's do inequalities. We're gonna do all the inequalities. We're not just gonna do I might jump through I might jump through sections just so that I could cover all of the inequalities. So let's do a really simple inequality first. We'll do some graphing with the inequality. So we're gonna do the inequality, then we're gonna graph it, and we'll see how it goes. And it will also do inequalities where we don't need to graph. Let's do first inequality is 3y is greater than or equal to 2x minus 2. So what does this look like? Well, I'm gonna make it so that it's in the form y equals something first. So this will be, or yeah. So y, and then an operation, or not an operation, a comparison, and then something that has x stuff in it. So this will be y is greater than or equal to 2x minus 2 over 3. So this means y is equal to greater than or equal to 2x over 3 minus 2 over 3. Now, to do these problems, you have to recognize where y is higher than the graph 2x over 3 minus 2 over 3. But how do you recognize when y is higher when you don't even have the graph yet? So you need to make the graph. So how do you make the graph? Well, I'm just going to eyeball it. You guys probably can't do this, but well, we have the x-intercept, which is 1. And then we have the y-intercept, which is negative 2/3. So it's like something like this. And then if you draw a line through it. So now it's a little bit easier to visualize, well, where is the y higher than this equation in this case? So y is equals to 2x minus 3, 2x over 3 minus 2 over 3 on this line. So y is greater than or equal to 2x over 3 minus 2 over 3 when y is higher on the graph. And that means this portion right here. Or let me draw it nicer. There you go. This portion of the graph. All right. There are, I don't know if there are new viewers or not, but if new viewers are coming in, I'm just doing this. I'm just like going off tangents right now. So if you guys actually want to have me answer the questions that you guys pose, just put it in the chat. I really have no program. I'm just kind of following the book all the way to chapter 4. If you guys have a question, please pose it in the comments so that I can do the question or do whatever concept you guys want me to do, because I don't want to I don't want to, what do you call it? I don't want to just go through the entire review and kind of not take in any viewer input. So just give me what questions you need, because your question's probably more important than this, and a lot of people are probably more confused on your questions than all the stuff that I'm going to be reviewing if I'm not answering questions. So I recommend you ask questions. All right. So I think number line sketching is something you also do. So if we just had 3 is greater than or equal to 2x minus 2, how would this work? Well, we have to get x is something, right? So what you would get is, well, if you add 2, 5 greater than or equal to 2x, and x or 5 over 2 is greater than or equal to x. So I can flip the sign. Since 5 over 2 is greater than or equal to x, or I can just leave it like this, actually. I can use a number line like this. I can put 0, because 0 is very important. I can put 5 over 2. I'm going to say 5 over 2 is like right here. And since 5 over 2 is greater than or equal to x, that means 5 over 2 is the greatest. So x can be 5 over 2, but x can't be greater than 5 over 2. It has to be less than 5 over 2. So x is right here. Right there. That's the values possible for x. And you'd write this as, in inequality notation, you'd write this like this. In set builder notation, you'd write it as, you'd open x such that x is greater than or equal to 5 over 2. And I don't even know if I remember set builder notations clearly, but that's what I've been taught. So that's how you would label your answer in both notations, the inequality and set notation, set builder. Now, what if we had something that's a little bit more complicated, like y is greater than or equal to 2x squared minus 5x plus 3. And then we'll also have negative 3 is less than 2x squared minus 5x. So these are nearly identical questions, but actually I'm going to make them minus so that the question's actually possible. Give me a minute. This minus this becomes plus. Okay. Yeah, so now the question's actually possible. So when you see a quadratic like this in one of these questions, what I recommend you to do, like any inequality question, quadratics, well, if you see any quadratic, your first instinct should be to factor. How you're gonna factor this? Factoring, if you see whole numbers like this, it's usually not going to give you a fraction. You're usually not going to get a fraction from factoring. So that means we can put 2x here, we can put x here, like this, and we can factor the method that we want to factor. There's a couple of other ways to factor, like the snowflake method, which I should show you guys. I should show you guys the snowflake method. But this way of factoring is the fastest. It just like visualizing it is the fastest. So, well, which number when you multiply by 2 and then add by the other number gives you negative 5? A little bit convoluted. What I do is I just do, well, 2 times negative 3 is negative 6, which is a little bit less than negative 5, but the magnitude is a little bit greater than negative 5. So I realize that this is minus 3. Minus 3, 2x makes negative 6x. So I just need an extra x to get me to negative 5x. And, well, gladly or luckily, I can add a +1 here, and then everything works out. 1 times negative 3 gives you the negative 3. The negative 5 combination works, and 2x times x gives you 2x squared. Now it doesn't work all the time like that, obviously. I'll show you guys the method that I use, or the method that I find kind of ingenious. It's called it's called the snowflake method. So it relies on this kind of shape. Is like a hexagon shape thing, sort of thing. So you put, if you label the quadratic as ax squared plus bx plus c, you put a times c here, you put b here, you put a on these two, and then you simplify, or you put a on these two corners, and then you put the two numbers right here. So these two numbers are what? These two numbers are the numbers that multiply to a times c, negative 6, and add to b, negative 5. So what two numbers multiply to negative 6 and add to negative 5? It's negative 6 and 1. Negative 6 plus 1 is negative 5. Negative 6 times 1 is negative 6. Now, you're going to put the two a's, so 2 here and 2 here, right? This is a really genius strategy. And then you're gonna treat these as fractions. Now they're not really fractions, but you're gonna treat these left side and right side as fractions. So 2 over 1 here, 2 over negative 6 here. This can't really be simplified anymore. 2 over 1 is 2, but it's like, well, it's 2 and 1. So it can't really be simplified unless if you like just make it a number. This, however, this fraction can be simplified into 2 over negative 6 is 1 over negative 3. So what you're going to end up with is the left side, 2x plus 1, and the right side, x minus 3. 2x plus 1 and x, or 1x minus 3. 2x plus 1, x minus 3. I like that method. I don't know if it's good for you guys. I don't know if you guys understood it at all. If you don't understand it, just ask me. We'll do some practice with factoring. And I guess there might be an easier way to do it as well. I think black pen, red pen has some ways of factoring that's also easy. So if you are interested, watch black pen, red pen. Anyways, this stuff I'm gonna put to the side. I think that's the... Alright, I'm gonna put this like right here. Because now we need to answer the actual question, and the question is, when is y greater than or equal to 2x plus 1 over x minus 3? Now this is a little bit harder. So let's draw a graph of 2x plus 1, x minus 3. Just a really rough graph. So x is equal to, the x-intercepts are x equals negative 1/2, like right here, x equals 3, like right here. So the intercept is, or the axis of symmetry is in the center of the two roots. That's always true, and it's never false. It's negative b over 2a. That's how you find it out. But it's also just the average of the two roots. Now, looking at this graph, I mean, common intuition would tell you that, well, the point where y is bigger than 2x plus 1, x minus 3 is, or is going to be this range right here. This range. And you'd be right. That's the right answer. It's in this range right here. How do we know? What we can do is we can test a point. We can test a point. Wow, there's a lot of viewers right now. So there's 6 viewers. I'll say this again then. If you guys want me to answer your questions regarding the upcoming honors pre-calculus final, please put it in the chat. I will answer your questions. I'll stop what I'm doing and answer your questions. The acidity problem in chapter 2. We'll find that later. We'll find out. We'll find that out. Acidity problem in chapter 2. That one. I think it's that one. 32. We'll do 32. Yeah, so what I was saying about this that inequality was that you can test points. Oops, I'm sorry. Paste right here. We'll do that. Yeah, you can test points. So if you put if you put into the equation x equals 0, you'll get negative 3, right? Negative 3 is right here. Well, you can see that, well, if y is greater than or equal to negative 3, then y must be negative 2 or negative 1 or 0 or 1, 2, 3. So it has to be the upper part, the part that is opening, the part that the parabola is opening in. right? And similarly, if it's less than or equal to, it would be this instead. It will be the outside. Um, because then if you have -3 right here and y is less than or equal to -3, then it would be -4 or 5 or 6 or 7. So it will be under the parabola. Mixing problem. The chemistry lab at the University of Hardwoods keeps 2 acid solutions on hand. One is 20% acid, one 35% acid. How much 20% acid solution and how much 35% acid solution should be used to prepare 25 liters of a 26% acid solution? All right. So let's see if I still remember how to do this. All right. So let's say that the amount or the liters of acid number one, yeah, I'm gonna say acid, the 20% acid, liters of 20% acid is equal to uh A, and liters of 35% acid is B. So the first equation will be number of liters. So the number of liters is 25. A plus B is 25. That's the total number of liters of acid that you will get. So the liters of 20% acid plus the liters of the 35% acid will give you the end liters of the 26% acid solution. The second equation will be the acid equation. It will be the amount of acid that you will get. So how many liters of acid you will get. So this is, I'd say this is the liters equation. This is the acid equation. So the acid equation is, well, if you're using 20% acid or concentrations of 20% acid, that means the total amount of acid will be 20% your number of liters for the solution A right here. So 0.2 A, which represents 20% of the total volume in solution A, plus 35% total volume in solution B is equal to 26% of the total volume in solution C, which is 25. This is going to give you a simultaneous equations. It will give you a system to work with. Now I'm going to simplify this. This is 1.6.5, I think. 6.5. So there's a total of 6.5 liters of acid. 0.2A plus 0.35B. Let me see if there's any question. All right, I think it's fine. So we're just gonna solve this normally. I prefer elimination. If you guys want to see it both ways, tell me in the chat. But I'm gonna do it on elimination, and if you don't need me to do it both ways, then I will just do it. I'll just stay with elimination. Substitution is quite easy as well, and don't even ask me about graphing because that's strange. So A plus B is 25. When I multiply this by 5, why? Because that will get me A plus something, and then A plus something. So I can subtract the A's and have only B's. This means that A plus 1.75B is 32.5. And A plus regular B is 25. Now I will subtract the two solutions, or subtract the two equations. So subtract. A minus A is 0. 1.75B minus B is 0.75B. And then 32.5 minus 25 is 7.5. That means B is 10 liters. If B is 10 liters, A is 15 liters. So 20% acid, 15 liters, And I think you guys have to write a sentence. So I'm gonna write a sentence with you guys. But 35% acid, 10 liters. So to make a solution with to make a solution of 25 liters of 26% acid, you must mix 15 liters of 20% acid and 10 liters of 35% acid. Dot. There you go. Very simple, straightforward sentence. Any questions? All right. Let's keep going. So let's go back here. 2x squared minus 5x, 3 is less than 2x squared minus 5x. So with these equations, well, if it's even if it's an equation or an inequality, what I would probably prefer to do is I move everything to one side, equals 0 or comparison 0. So whatever x stuff equals, less than, greater than 0, right? So I'd say 2x squared minus 5x minus 3 is less than, greater than, equal. In this case, it's greater than 0. So then I can decompose it into the 2x plus 1 and x minus 3 is greater than 0. And then this will give me x is equal to negative 1/2 and x is equal to 3. If I set it equals, if this was equal to 0, then this would be the answer. So I'm gonna say if this was equal to 0, then this would be the answer. But it's not. It's not equal to 0. So you have to do something. You have to do something called well, you have to use a number line. You have to do something called I think it's called a sign chart. It's a sign or sign line. I'll call it a sign line. Why do you have to do a sign line? Well, this is the problem right here. When graphs pass through 0, when graphs pass through this x-intercept, what can the graph do? The graph can stay at 0, which usually doesn't happen. The graph can be like, and stay at 0, which usually doesn't happen. The graph can cross through. In this case, there's a sign switch. Or the graph can bounce, which in that case, there's no sign switch. But where can the sign switch? Where can something be start being less than or greater than 0? The sign can only switch at 0. That's why I want everything on one side and then 0 on the other side. Now, it obviously doesn't work if there's y and x. If there's y and x, you just have to graph it like this. But if it's x only or y only or t only with numbers, one side is 0 and the other side is x stuff. That's the easiest way to solve an inequality. If you solve it any other way, if you solve it like this, as this, you will have a very hard time plugging in values and it will be very annoying. This is the easiest way because, first of all, this equation's easy to solve, and second of all, if you pass 0, if you cross 0, you can more accurately determine whether or not the sign switches, the sign doesn't switch, or it stays at 0. So we're going to put our two zeros. We're going to put one at negative 1/2 and 3. So this is negative 1/2 and this is 3. So we're looking for the spots where this is positive, right? We're looking for the specific locations where this equation's positive. So where is it positive? Um, the method, the kind of foolproof method is to test points. Um, if you guys know enough math, you guys can realize that, well, 2x squared minus 5x minus 3 opens up because it has a positive a value, it has a positive x squared coefficient, so it opens up, so it automatically be plus minus plus. This means that this side right here, this side, only positive values, only positive values. Look, only positive values until it gets to 0. And then this side, negative, only negative values until it gets to 3. And this side, positive values again. So it can't change signs unless if it hits 0. That's why I'm finding the zeros, because it can't change signs if it doesn't hit 0, so that's why I'm finding the zeros. And this positive, it what you can do is you can just test a point. You can test an x value. So for example, if you can't use any other strategy, you can test x values. It'll work all the time. So if you test, for example, what's a smaller number than -1/2 that's in this range is -1, right? So you can test -1. You can see, well, -1 is going to give you 2 plus 5 minus 3, which is 4. 4 is a positive number. So this entire area is positive. Why is the entire area positive? Because it didn't reach 0. It didn't reach 0 until -1/2. So at -1, it's positive. At -2, it's positive. -3 is positive. -4 is positive. If it was negative, if 4 was if at -1 x was negative, then everything else had to be negative because it didn't cross 0, right? Of course, it doesn't work every time. This does not work if the equation is piecewise, if the equation is discontinuous, if there's a hole in the equation, if there's like a hole in the equation, it's not gonna work. It can jump signs. But with polynomial equations like this, ones that you know are continuous, this works. Test point here. In this range, what is a nice number between -1/2 and 3? 0. So if you put 0 here, you get -3. -3 is below. So it has the entire range has to be negative until it hits 0 again, in which case it's positive again. You can test a point. 5. 2 times 5 squared is 50. Minus 5 times 5 is 25. 50 minus 25 minus 3, 22. Positive. Transformations of 1 over x. Okay. Transformations of 1 over x. 1 over x looks like this. Right here. Let me do this real quick. 1 over x looks something like this. Alright, let's do a couple of transformations. We're gonna do first of all, we will do f of, well, we're gonna say that f of x is 1 over x. And we're gonna say that we're gonna try to draw, I'm gonna try to draw on the same graph. F of x minus 1 equals 1 over x minus 1. So what does this look like? F of x minus 1 is equal to m over x minus 1. If you forget these transformations, you can always use certain strategies, certain points in the graph that you know will happen in order to figure it out. So, for example, in this 1 over x minus 1, if the bottom is 0, it's a vertical asymptote. If the bottom is 0, it's discontinuous. Like this one, 1 over x, the bottom is 0, so there's an asymptote right there. If it's 1 over x minus 1, that means there's an asymptote at x equals 1. So the graph, or by like in some type of mathematical reasoning, you should expect the graph to be shifted by 1, the entire graph to be shifted by 1 as well, in addition to the asymptote. If I can draw one well. Similar for the other side, x plus 1. X plus 1, you will get 1 over x plus 1, which means that the asymptote has to be at x minus 1. X equals minus 1, right there. We'll get like this, if I can draw it right, and like this. That's the equation. All right. Let's continue, because this is not all of them, obviously. What about f of x plus 1? What about we have, well, let's continue on the graph. So if we have, this is, let's say this is f of x equals 1 over x. And these work for all of the functions. These rules, general rules, right here, work for all of the functions. If it's x minus 1, it's moving 1 to the right. X minus a, moving a to the right. X minus x plus 1, moving 1 to the left. X plus a, moving a to the left. All functions, it will work. For all functions, it will work. For this function, specifically, obviously, it's going to work. So, if f of x plus 1, what you'll get is 1 over, or 1 plus 1 over x, or 1 over x plus 1. This can be tricky. Why can this be tricky? This can be tricky because what you can end up getting is, instead of them writing this, they can write it like this. They can write it as x plus 1 over x. And this sucks. This is not a very nice thing to write it as. This is not a very known form. It's not one of our known forms. It's not going to be one of our known forms. So what you have to do is you have to divide it through. Once you divide x plus 1 by x, you'll figure out that x plus 1 over x is just this, 1 over x plus 1. Then you can draw the graph. Well, you can draw the graph. This is right here. I'm going to make that blue, so this is black. And then this is blue. What's the difference? The difference is the difference is the horizontal asymptote just got shifted up by 1, and the entire graph just got shifted up by 1. The vertical asymptote stays the same, still at 0. So plus 1 shifts it up by 1, minus 1 shifts it down by 1. Okay. Let's do the next one. Let's do 1 over 2x. Or let's do f of, oops, sorry. F of x, or f of 2x, and then f over 2 times f of x. So by looking at this, you can tell that, well, 1 over 2x is, I'm going to make this blue, and I'm going to make the bottom one red, purple. 1 over 2x is going to grow way slower than 2 over x. 2 over x is going to be high, like really fast. And that's basically what it does. So 1 over x, it looks like this. I've drawn it many times already. 1 over 2x is, the higher the number, the more it gets squished. The more it gets squished in horizontally. It gets squished in horizontally. So stuff inside the function is usually horizontal. So the shifts, like these shifts, they're horizontal shifts, and then these right here, horizontal. They're horizontal. This is a horizontal squish or a horizontal. It's not a stretch, but it's a shrink. So this is a horizontal shrink. 2x means that, and you can tell because well, the if I put in 1 for x, I'm not getting as high of a value. So what you're gonna end up getting is something like this. Something like that. It's gonna be a horizontal shrink. I can't draw. So yeah, I think I use like imagine there's like imagine you're squeezing something right here, or imagine there's a hydraulic press squishing the graph from the left and the right, or piston squishing the graph from the left and the right. It's going to give you a more squished in graph closer to the y axis. Now 2f of x hires the height, gives a higher height rather than a higher length. Higher height. Oh yeah, or no, not yeah. So it gives you a higher height. It gives you a higher height, so it's a vertical stretch, um, which will end up giving you higher values. So 2f of x may look something like this, right there. Obviously, the results are not very clear here. How do I make the results more clear? To make the results more clear, I'll illustrate it with something, your favorite function, not really, sine. So g of x is sine. So sine looks like this. Let's draw the line a little bit bigger. Let's make that 1, let's make that 2, let's make that -1, -2. Right, something like that. Something like that. There you go. So if I did f of, or g of 2x, that's sine of 2x. Sine of 2x, if you've learned about the anatomy of a graph, of one of these type of graphs, sine of 2x makes the period 2 times shorter, makes the frequency 2 times faster. Why? Because if I put pi, if I put pi here, this has only gone through pi revolutions. It's only gone through pi amount. But this has already gone through 2 pi of the circle, of the unit circle, right? This has only gone through pi of the unit circle, but this 2 pi of the unit circle. So sine 2x is twice as fast as sine x. So it'll look something like this. Excuse my bad drawing. It will still oscillate. It will still oscillate within -1 and 1. It will not change oscillating from -1 and 1. It just is 2 times faster. Now what about 2 g dx? 2 times g of x is 2 sine x. So in this function right here, in the blue function, sine can only be from -1 to 1, right? There's nothing multiplying sine to make it more than -1, or more than 1, or less than -1. Sine can still only be from -1 to 1 in sine x or sine 2x. In sine 2x, it moves faster, but it doesn't mean it gains more juice. It does not gain any more juice. So 2 sine x right here, that does give it more juice, but it doesn't make it faster. So this is what I mean by horizontal squish, or horizontal shrink, is there's kind of external forces pushing the graph in from both sides. Pushing the graph in from the left, pushing the graph in from the right. If this was g of 1/2 x, they will be stretching the graph out. But it's g of 2x, so it's pushing the graph in. 2g of x, we have vertical stuff stretching the graph out. If it was 1/2 g of x, it would be pushing the graph in. But just from this sine x graph, intuitively, you can say that, well, sine x is only from -1 to 1, so this is not going to give you a value that's more than -1, or more than 1, less than -1. It's only going to be the fact that it's 2 times faster, because if I put pi in here, this will already be 2 pi along the unit circle. This will only be pi along the unit circle. So the graph looks something like this. Alright, I'm really bad at drawing. There you go. That is the graph of 2 sine x. So let's... Alright, I think... do you guys have any more questions? I'm going to stay for about, I don't know, 4 more minutes. And then I will leave if you guys don't have any more questions. I don't know. I don't know if I'll do it tomorrow as well. I might. I might do it tomorrow. Uh, I might do this tomorrow. Although I also have stuff to prepare for tomorrow, so it won't be a very long one tomorrow either. Um, oh, I'm sorry. I'm missing two more transformations. Let me do those real quick.
Chén bát rửa con. Anh hai.
Yeah.
Ồ, không, úp vô máy ba rửa chưa?
Yeah.
Ủa,
Yeah.
Chơi trong
Yeah, không có chơi kia.
xong rồi
Yeah,
nữa úp
yeah,
nha.
yeah.
Còn nhắc thôi.
Alright, this is bad. Yeah? I do not know what's happening right now. Let's erase this. Let's do the blue. Let's make this purple. Negative f of x is -1 over x. Now sine is a odd function. Or no, not yeah, sine is an odd function, obviously. But 1 over x is also an odd function. Why is it an odd function? It's an odd function because these two are exactly the same. F of negative x and negative f of x are exactly the same, gives you the same graph. There are graphs that don't give you the same thing. So I'm going to draw these right now. What is this? F of negative x right here. This is a reflection on the x-axis. Or no, I'm sorry. That's wrong. That's completely wrong. This is a reflection on the y-axis. Y-axis reflection. So f of negative x is 1 over negative x, y-axis reflection. If the original graph is like this, then the y-axis reflection is like this. If I can draw. There you go. This is an x-axis reflection. So this negative f of x equals negative 1 over x is it will reflect on the x-axis, so it will also look like this. Unfortunately, the graphs are the same because it's an odd function. That's what an odd function is. An odd function is when this is the same as this. F of negative x is equal to negative f of x. That's an odd function. An even function, I guess this is good to know. An even function is when f of negative x is equal to f of x. So that's even and that's odd. Right, please ask away if you haven't. I'm going to stop the stream after I finish this. So ask the questions while you are, or tell me to wait. Ask the questions or tell me to wait. So f of negative x equals negative f of x. F of negative, yeah, this is odd and even. Odd functions, when you rotate it x axis or when you rotate in the y axis, you get the same graph. However, one graph that's definitely not odd is the graph of e to the x. Let's do g of or h is e to the x. So the e to the x function looks like this. That's one of the nicest e to the x functions I've ever drawn. So following that logic, h of negative x is negative, or no, is e to the negative x. So wherever you see x, you replace it with negative x. What does that look like? That is a y-axis reflection. So it looks like this. That was pretty good as well, but it's not as good as right now. So that's y. That's blue, I mean. Purple, negative h of x is negative e to the x. That makes all the values negative, right? This doesn't make the value negative, any values negative. This makes the values negative. So this is an x-axis reflection. Now we combine them both, which I'm gonna make it that red. So negative h of negative x is negative e to the negative x. You'll get both. You'll get it reflected across the x, and then you'll get it reflected across the y. This looks pretty nice. Let me make sure it has the same y-intercept. All right, there you go. So yes, if it's h of negative x, reflection on the y. Negative h of x, reflection on the x. Everything that has to do with horizontal is inside the parentheses, right? This looks like a horizontal reflection. Horizontal reflection. This looks like a vertical reflection. Sure enough, it reflects on the x-axis, reflects vertically. This looks like both. So it's gonna go do some horizontal stuff. It's gonna do some vertical stuff. What if we had something really nasty like 4x minus 7 over 2x plus 3, then we'd have to simplify that. So h of x is equal to this. We'd have to simplify that. We'd have to do some division. So this would be, I'm going to create some variables. I'm just going to say that this is 4x plus 6 minus 13. So minus 7 is 6 minus 13 divided by 2x plus 3. 4x plus 6 over 2x plus 3 is 2. So it's 2 minus 13 over 2x plus 3. Now I can simplify this. This is equal to 2 minus 13 over 2 times x plus 3 over 2. And there I go. I pretty much got everything that I want. So analysis on this function, which one is which? Well, this x plus 3 minus or this x plus 3 over 2 is a 3/2 shift to the left. This 2 is a horizontal shrink. Shrink. This 13 is a vertical stretch. This negative is a y-axis, or no, I'm sorry, x-axis reflection, or y. I think it works with y as well. And then this 2 is let me use another color. Brown is a translation, or 2 up, 2 shift up. So what will that look like? That will look pretty messy. Um, well, you can actually notice right here, that this is simply just, or this is just 1/2 times 1 over x. So this f of 2x right here is a horizontal shrink of 2. Horizontal shrink by a factor of 2 is also a vertical shrink by a factor of 2. So they're both, so this is a vertical displacement by a factor of 2. This is, or by a factor of 1/2. Vertical displacement by a factor of 1/2. This is a vertical stretch by a factor of 2. So right here, what I can say is this is also a vertical stretch by a factor of 13 over 2. Rather than saying it's a vertical stretch of 13 and then a horizontal shrink of 2, I can just say it's a vertical stretch of 13 over 2. And that will make it a little bit nicer. Not very much nicer, though. So I'm just going to use a color that I haven't used yet, orange. Shift 3 halves to the left. So at -3 over 2, the graph is undefined. So that's your asymptote. Right there. 2 shift up. So at 2, you have a horizontal asymptote. It looks like a massive graph. And it's also an x-axis reflection. So it doesn't look like this, because this would look like a regular graph, but instead it looks like this. And it's also really huge, so it's probably something like this. It's probably not close to the x-axis at all, so it probably looks very far away because of the vertical stretch. So look, something like this, right here. Very far away from the x-axis because it's a vertical, or from the horizontal and vertical asymptotes because it's a very far vertical stretch. And that's it. I will continue with a review next tomorrow if there's enough demand. And I hope you guys have a good time studying and good luck for the final. I don't know why I'm recording this. Why am I recording this? I'm only supposed to be streaming. Good luck for the final. And I